Look closely at the physical world around you. From the microscopic components inside your smartphone to the massive turbines of commercial airliners, every manufactured object relies on a hidden foundational technology to exist. That foundation is the machine tool. Often called the mother of machinery, these are the machines used to build other machines. If you want to cut, bore, or shape metal with microscopic precision, this is the equipment that does the work. Controlling this technology means controlling the very seeds of production. A country that can design and build its own machine tools dictates its own industrial capacity, rather than relying on foreign imports to sustain its factories, infrastructure, and defense. You might expect the heart of this manufacturing power to be evenly distributed across the world's largest nations. Instead, a massive percentage of this precision capability is locked within one specific high-density geographical corridor. That corridor is located in central Taiwan, running directly along the foothills of the Dadu mountain ridge. This data from 2018 shows the exact distribution of Taiwan's massive machine tool industry. A dominant 58.5% of the entire sector is concentrated right here in the central region, far outpacing the production capacity of both the north and the south. The defining feature of this hub is its extreme density. We are looking at a continuous industrial belt that stretches for merely 60 kilometers. The concentration peaks in 3 specific districts: Taiping, Fengyuan, and Shandong. Within these boundaries, thousands of specialized factories operate in a tightly packed, interconnected grid. This isn't just a collection of factories, it's a localized ecosystem. By condensing thousands of specialized suppliers into a few dozen miles, Central Taiwan has turned this valley into the primary engine of its precision export economy. To understand this clustering, we must look at the technology's evolution. It began with 18th-century manual machine tools. By the 1950s, numerical control introduced automated instructions. The 1970s breakthrough was CNC, integrating computers to automatically execute complex geometric shapes. But as CNC machines grew more sophisticated, they became too complex for a single factory to build every part from scratch. A manufacturer would need thousands of unique, high-precision components just to assemble one unit. To manage this complexity, isolated factories evolved into a localized network. They moved closer to their specialized suppliers, turning the Dadu mountain foothills into a giant open-air assembly line. This ecosystem thrives because of 6 specific location factors: land, labor, capital, the industrial cluster itself, government policy, and transportation infrastructure. Access to transportation is non-negotiable. Machine tools are massive, heavy pieces of equipment. As this map shows, the factory clusters are positioned for rapid access to Taichung Port, which is vital for moving these heavy assets into the global market. Within the cluster, factories are linked like a food web. Raw materials and specialized parts, like precision bearings and hydraulics, funnel into the machine tool builders. Those finished machines then power downstream sectors, from aerospace to medical device manufacturing. The advantage of this density is speed. A builder can source a component, consult with a specialist, and finalize an international order, all within a 60-kilometer radius. This creates a competitive advantage that is physically rooted in the landscape. Because these specialized skills are concentrated in hundreds of local workshops, this network is difficult for competitors to replicate or move abroad. But even this dense network is facing new threats. The traditional model of the Golden Valley is being challenged by shifts in the global economy and local workforce. As this analysis points out, the industry faces a demographic crisis. A lack of young talent entering the field has created a technical gap, threatening to erase decades of specialized manufacturing knowledge as the older generation retires. At the same time, global demand has moved away from standardized mass production. The market now requires mass customization, small batches of highly specialized parts that need to be delivered faster than ever before. Physical proximity alone can no longer solve these problems. To handle the speed of modern logistics and the loss of manual expertise, the industrial ecosystem has begun to develop a digital nervous system. This is the transition to Industry 4.0. It marks the shift from automated factories to smart manufacturing centers. The core of this shift is the Internet of Things. By connecting machines and orders to a common data network, individual components can communicate their status and requirements without human intervention. This creates a self-monitoring ecosystem. Machines use big data to optimize schedules, perform maintenance checks, and adjust to supply chain shifts in real time. The 60-kilometer corridor is now overlaid with a digital network. Information travels between suppliers instantly, making the physical movement of parts even more efficient. The Golden Valley demonstrates how geographic density, when fused with digital intelligence, transforms a traditional manufacturing hub into a self-correcting network, ensuring it remains the foundational engine of modern machinery.